Welcome to this video on Hooke's Law. Hooke's Law is a fundamental principle in physics that describes how elastic materials, like springs, behave when stretched or compressed. Simply put, the force needed is directly proportional to the distance of stretch or compression. The formula for Hooke's Law is F equals negative kx, where F is the applied force in newtons, x is the extension or displacement in meters, and k is the spring constant, measured in newtons per meter. The spring constant represents the stiffness of the spring. The negative sign indicates that the restoring force exerted by the spring is in the opposite direction of the stretch. However, for simple calculations of magnitude, the formula is often written as F equals kx. Hooke's law only applies up to the elastic limit. Within this limit, the material exhibits elastic behavior, snapping back to its original shape. Beyond this, plastic behavior occurs, leading to permanent deformation or breakage. Hooke's law has many real-life applications. Examples include car suspension systems, the mechanism in retractable pens, spring scales for measuring weight, and guitar strings. When graphing force versus extension, the resulting straight line slope is the spring constant, K. If the line begins to curve, Hooke's law no longer applies. This graph illustrates the relationship between force and extension, showing a clear linear relationship initially, consistent with Hooke's law. The gradient, m, is calculated as the change in force over the change in extension. This example calculation results in a spring constant of 70 newtons per meter. The gradient of the force versus extension graph represents the spring constant, k. This is derived directly from rearranging Hooke's law.